Hello, everyone. I'm Nate Fields, Associate Editor for Modern Machine Shop, and I'll be your moderator for today's webinar, Unleashing Productivity, Purchasing a 5-Axis CNC Machine, brought to you by Hurco. The overall goal of this presentation is to guide participants in making a well-informed purchase that maximizes productivity and unleashes the full potential of a 5-axis CNC machine. Our presenter today is Mike Cope. Mike, author of the book The Power of Five, The Definitive Guide to 5-Axis Machining, is currently a senior applications engineer and a product technical specialist with Hurco. He has been with the company since 2005, but has been in the manufacturing industry since 1984. Most recently, before coming to Hurco, he owned and operated a small job shop for several years. Before we get started, just a couple of housekeeping notes. First, I want to direct your attention to the panel that's probably on the right side of the screen. You'll see a tab that says Q&A. So if you have any questions at any time during the presentation, submit them there and we'll answer as many as we can at the end. The webinar is also available in the handouts tab. You can see the slides there if you download that PDF. And also note that this webinar is being recorded. So if you're not able to stay for the whole thing, or if you want to refer back to it or share it with a colleague, you'll get a link to that recording via email, usually within a few hours. And with that, I'll hand it over to you, Mike.
All right. Thank you. All right. So here's what we're going to cover today. We're going to go through a little bit of an introduction to 5-axis. Not everybody has the same level of knowledge for 5-axis. So I want to talk a little bit about why we see the growth in purchasing machines in 5-axis. We'll talk about some considerations you should have when you're looking to purchase your first 5-axis, a little bit about work holding, and then we'll go into some benefits of each one of the different configurations. So why 5-axis? First thing I like to start out all of my 5-axis presentations with, especially when we talk about the technology, is this customer quote. Well, you just position and cut, and it makes every operation just one operation. If you're not doing this, meaning 5-sided machining or using a 5-axis machine, then you're going to get left behind, because most shops have gone this way, and I'm sure that means your competition is definitely doing this. So what are the challenges that are driving 5-axis, the purchase of these machines? Well, batch sizes are getting smaller, meaning when a purchasing agent orders the product from their suppliers, they're not ordering such large quantities anymore. So those batch sizes are smaller, meaning that we need to be able to utilize the equipment we have to get things done a little bit quicker, more efficient. The delivery times have been shortened. In the days of just-in-time manufacturing, they're requesting these parts when they need them, not necessarily projecting out for the entire year. So we need to be able to react quicker. And lead times can change, meaning that a customer may have you working on a series of parts, and there's a due date for those coming up, and all of a sudden his needs change, and he needs to have you jump off of those and work on something else that he didn't realize he needed, but they're out of. So for us to be able to react quickly, that's a lot easier to do when we're doing one-off type operations rather than 6 or 7 different operations to get a lot of parts done. So that's kind of the challenges that have been causing us to see this spike in 5-axis machines. The benefits, there are several benefits when going to 5-axis. It's going to provide the ability to machine multiple operations in a single setup. I think everyone kind of understands that. It's going to give us significant time savings when we're cutting parts that have compound angles and other things where we typically would have to build up some kind of fixturing to hold the part at an odd orientation. And we'll see some examples of that. Even have one example where we put some numbers and some time to those. We're able to machine complex parts from a solid billet rather than castings, so we don't have to invest the money in castings for short runs or for prototype work. We can just get a billet of material and machine everything away. And it enables us to use shorter cutting tools when we're cutting deep cavity features. In an example like this, if I'm going to be cutting this, where's my mouse? This little deep cavity here, I'm going to have to use a longer tool to reach down in there to go on this vertical wall. And if I've got real small radiuses in these corners, then that means that tool is not only going to have to be long, but it's going to have to be very skinny, and that doesn't cut very well. So 5-axis allows us to take a part that is basically a simple part, but we're able to apply some tool path on it to keep that tool tilted. So we're able to reach down in there with standard length tools or a little bit shorter, more rigid tools. We can cut better, faster, better surface finish, and so on. When we talk about 5-axis, there's actually two sides of this industry that we're talking about. We're talking about 3+2, also known as 5-sided or positioning, which we see on the left. Very simple parts with multiple operations around every side of the part. Or we're looking at the very difficult or complex machining of something like this impeller blade we see here. But what's really driving the sale of these is shops that are trying to get away from things like this. We just have to do some simple geometry or some simple work on a specific side of the part. But to do that, we have to hold the part rigidly, and we go through a lot of pain and suffering to get things in position sometimes. And if you're only running one or two of this, then that even compounds this problem. So this is kind of what we've seen most of the sales are going to, is to eliminate this type of setup. But both sides of the 5-axis world, they have their own benefits. To simultaneous 5-axis machining, we're going to have better surface finishes because as we're running that tool, ball nose end mill, for example, we're able to keep it tilted and continue to cut on those flutes rather than at the bottom center of the end mill. That's also going to provide us a little bit longer tool life than dragging that tool along. Again, cutting with the bottom center. There's no surface footage there, so we're actually dragging more than cutting down there. But the biggest benefit is it's going to allow us to reach into areas that we cannot get from a 3+2 or any kind of vertical orientation. We need to be able to move that part while the tool tilts to get down inside the veins and so forth we saw on that part we saw under simultaneous. The benefits aside to 5-sided, and again, this is what's pretty much driving most of the machine sales that we see. And a lot of shops don't think they're doing 5-axis work, but they're already doing 5-sided work. It's easy to program. We're going to use that 5-axis machine to position that tool or that part into some orientation that we would typically have to build a fixture for. And then it's just 3-axis programming from that point. So it's very easy to program. It's easy for people to understand and make the jump. 3+2 cuts faster than simultaneous. That makes it a better strategy for just about anything that you don't have to go to 5-axis simultaneous for, because we're going to be limited by the slowest axis when we're cutting. And typically that's going to be the tilting axis of the machine. So if we're not including that, once we've locked it into position, then we have all of the linear feed rates available to us that we would typically have in 3-axis, but we're holding that part at whatever orientation that we need to cut. Don't have to worry about tool interference issues when I'm cutting in 3+2. When I'm in simultaneous, when I get to the end of a vein or something like that, that tool could unexpectedly want to tilt, causing me to have a collision. So I have to be very cautious about that. And I don't have those issues when I'm in 3+2 because the part's not going to move once I started machining. And all of those things make this an excellent roughing strategy. Even if I'm going to finish that part in 5-axis simultaneous, eventually it's still better to rough it out this way in many cases. So kind of looking at the two, the 3-axis versus 5-sided, again, I just wanted to kind of a few little bullet points to highlight the two. Multiple setups for each side of the part. Obviously, when we're doing 3-axis machining, we're going to have to take all those parts, run them through operation 1, flip them, run them through operation 2, and so forth. It's going to increase my setup time because I have to do a setup for each one of those operations. And the potential for decreased accuracy is there because every time I position that part, I can be on a chip, I can be up against a chip that's against my stop. Maybe I'm not pushing it as hard this time as I did last time. So a little bit of inaccuracy there could be introduced into the part just by me having to reclamp this part multiple times. In 5-sided, I'm going to reduce my setup times because I'm going to basically do 1, maybe 2 operations to finish this part on all 6 sides. It improves my part accuracy because once I've clamped that part, I just move that part throughout the space of the workspace and work on all sides. So I should be able to cut a part with good machining practices as accurately as that machine can position. And it is going to increase my shop capabilities overall. So although I may have a 5-axis machine right now to address some efficiency issues, it does open up the possibility to do some more complex work that I couldn't quote on without the existence of this machine in my shop for later on as I get more comfortable with it. So I said that we were going to put some numbers to this. So we kind of took apart, if you've seen any of my presentations that I've done in the past, I do use this one a lot because it really highlights everything that we want to show about going from 3-axis to 5-axis or 5-sided. So we did a part in a typical 3-axis machine using a 6-inch vise, and we took multiple operations to complete that part. Then we took the exact same part. We did it on a 5-axis machine where we were able to do it in 5-sided, and we took it from a total of 7 operations to 2 operations. So here was some of the numbers that we got in producing that part the first time. Again, it was 7 total operations. Setup time was 5.5 hours total. That included having to build some kind of a wedge fixture to hold it because those 2 angles on the part are not the same, and the programming for every one of the sides. We had a combined cycle time of 19 minutes and 47 seconds. We then put that same part on the 5-axis machine. We were able to do it in 2 setups. The first one was just to drill and counter bore the holes that we were going to use to mount it to the fixture. And then we completed the part 100% after that in the next operation. Excuse me. We dropped from 5 hours and 30 minutes to 1 hour and 30 minutes in setup. Again, we didn't have to machine those wedges, and we were able to do this all in one setup, so I didn't have to continually go in and find my part setup. And the total cycle time was 13 minutes and 4 seconds. Now, we expected this to see a drastic drop in the setup time when we did this, 4 hours. That made sense. But what we weren't really expecting, but we are beginning to see that this is pretty common on a multi-operation setup, is we lost almost 7 minutes in total cycle time because once I get tool 1 in the spindle, I'm able to hit all 5 sides of that part. Tool 2, same thing. Previously, I would have been using those same redundant tools in multiple operations, but I had to only use them when I was running that particular op. So this one surprises us a little bit, but we're seeing that it's pretty common that this cycle time will drop. The more operations you had in the original setup, obviously, the more you're going to see a benefit here. But if this was a job that I had in my shop already, this gives me the ability to get it done a little quicker, more efficiently. I'm either able to make some more money on it or recoup some money if I was on the edge of being proficient with that job, or I can now turn around and maybe offer my customer a little better price to help that relationship. So switching from 3 to 5, wrapping this up real quick, it's an easy transition to 5-sided work. Again, you're just positioning and then running 3-axis. It increases the shop capability, and then it makes that jump to full 5-axis easier and less scary when I finally decide to do that. So purchasing considerations. When I'm looking to buy a 3-axis machine, I typically want to buy the largest machine that I can get for the money that I have to spend. And although that's a good rule of thumb, not always will that transfer to 5-axis. We need to consider the individual part sizes or the family of parts that we're going to run completely. So all the parts that we think we're going to want to be able to run on this 5-axis machine, we need to take a look at the sizes of those. One of the reasons is the biggest or the most common machine people go to right away is a Trunnion style, an A-axis Trunnion style machine. And although that's a really good machine, it's a good choice, we need to think about, again, the size of machine we get versus the parts we're going to run. If you see on the left, let's say that this particular machine had a 12-inch diameter table, and I'm running a very small part on that. The 12-inch diameter table would hit the whole family of parts I want to run, but there's a very good number of those that are very small. Well, as you can see, because the tool approaches from behind this trunnion, when I roll over at 90 degrees, I have to come very far down with a standard length tool and tool holder So I've got collision issues that could be happening here with the spindle nose and the table. We see it back here with the casting. So to combat that, I'm going to have to increase the length of my tool and my tool holder, thereby giving up a little bit of rigidity just for this clearance. Had I sized the machine, the diameter of this table, a little closer to the type of work I was going to be doing, I wouldn't have this problem at such a drastic level. So that's one thing to think about, is what size parts am I going to run? If it is this type of machine I'm looking at, a standard Trunnion, then I kind of need to think about what size fits my needs better. Next, we want to look at the part setup or the fixture design that we're going to use. These, the setup like we see over here in the picture on the left, these are very popular. They're a great solution. They give us a lot of flexibility. They're very accurate. They're quick to change over between parts. And on any 5-axis machine, we don't really have an issue in our Z-axis travel. So I can stack those things up and be able to reach the top of the part without any problem. The issue comes then when I'm going to rotate 45 or 90 degrees. In this far left picture, we see the y-axis of this machine is as far forward or in the negative direction as it will go. We have no more travel in the negative y. And while we're at 0 degrees with the tool or the part vertical, we have no problems. I can machine that part completely. If I go to 45 degrees, you can see that we still are able to get everything on that part without running out of travel because I have no more travel forward. But when I go 90 degrees, I don't have any more travel, and you can see I'm not even to the top of the part yet. So this distance from the table face to the center of the spindle at maximum y-axis negative travel, that's a very important number for you to try to gain from whoever's machine you're looking at, because that's going to determine the height of the part and fixturing that I can run on that particular machine without running out of travel. And this is what we see a lot when customers are getting out of travel limits. There are some programming things that we can take care of there, but typically it's because of this. Their part's too tall and they just can't get there. The machine physically can't reach it. The next one is we need to consider the length of all of the tools that we have that we're going to be using in a particular job, particularly on a swivel head machine. Here we see a part that's sticking out in the x-axis. We've got a fairly long drill. Maybe we need to drill. This is a manifold. Maybe you have to drill fairly deeply into this. In this case, I'm going to be moving X all the way positive to allow this tool to be able to drop down into position. In this particular case, I don't have enough x-axis travel. I would have to shorten that tool up to be able to clear the part. This might push me towards a combination of the tool and the part might push me towards the next size machine that I would have been considering because of this this condition here. Or I might have to consider a group of parts that I can't run on this type of machine because of this condition. So again, there's way more to consider when I'm looking at a new 5-axis than just in a 3-axis machine. In the XYZ travels, tilt angles and so forth aren't always telling the whole story. I really have to take a look at the processing and how I'm going to process these parts to determine if there is any of these type of issues that show up, or even ones that we may not have discussed here that I can see coming down the pike because of the way I'm going to be holding a part and so forth. So work holding is another good thing to talk about. We have there are so many different ways to hold the part, but I have to think about differently when I'm going to do 5-axis. A lot of the things we hear is people say, well, I can understand how a 5-axis machine could benefit me, but I can only hold one part at a time. Because typically what we see in trade shows and on the internet a lot of times is someone will have a centering vise like this, or maybe a dovetail, and it's holding one part. Although that's very good, it's being a lot more efficient with the time we have in that part, and we gain all the benefit. Something like this makes more sense. There are companies out there that create these OEM style fixtures that I can get where I can hold multiple parts at some type of an angle, and it's going to allow me to get around that part and do more than one. They offer some of these palletized systems here, so I can very quickly switch between different types of tool holders. They offer some where I'm able to take a dovetail fixture like this, mount a smaller one in it so I can get use of one fixture. Is going to allow me to do a much bigger range of parts. And we can even take that to the next level and put it in with some automation to be able to automate a system where I'm getting multiple parts off of one fixture, and I'm able to run that lights out overnight and so forth by doing some pallet changes or using automation to put multiple fixtures in. And now I'm able to get even more hours in the day under that spindle and be able to make a little bit more efficient work of it. The whole story is I got to be a little more creative with my fixturing. I can build my own type of fixtures. Here we've got just a simple round fixture with a bunch of parts on it. Again, it's going to allow me to do multiples at the same time. Here I've got an op 1 and an op 2 where I can just make my own type fixture, but still be able to do more than just one thing at a time. And we just need to think of our fixturing and our work holding a little differently. So here we see what we would typically put as 3 parts on the table, 3 6-inch vices. If I was on a 3-axis machine, I'd do all my work on this one, flip over and do some work on this one, and then on the far right part. But as a 5-axis environment, I can't get to the insides of these 2 parts. But if I simply rotated those vices on my table 45 degrees, now it opens up all 5 sides of that part, and I'm able to get all the way around it, machine all the work that I need to without having to give up the palletization, if you will, of being able to do multiple parts at one time. So machine configuration is the benefit of design. There are a few things that we want to talk about, and this will be the last little section here to kind of bring this home, but each design or configuration of machine has its own positives and negatives that we should be thinking about. Number one is probably the most popular. This is the AC Trunnion. It's the most recognizable one. People, when they think of 5-axis, often think of this style of machine. It's what we call a table, meaning that the tilt axis and the rotary axis are both housed within the table. So it's a table. It's one of the easiest for a machinist to visualize when he's going from 3-axis to 5-axis, because again, we're just going to position that part most of the time. You're just going to position it, lock it down, and then do some machining. But even in a simultaneous environment, this is easier for people to visualize. It's closer to a rotary than anything else. It's going to give us good undercut capability, but usually in one direction. So this table will tilt 110 degrees, for example, towards the operator, allowing me to cut underneath at some angle. So I've got that undercut capability, but it will only tilt 30 degrees in the other direction. That is because if I tilted the full 90 or 110, the table's going to be in the way. I'm not going to be able to see anything. The part may tilt backwards and run into way covers if I'm going to travel full positive in Y or negative in Y. So it typically is going to give me that benefit, but only in one direction. The other thing to think about with trunnions is we're going to be limited a little bit in part weight, not significantly. And the larger the part or the machine you get, obviously the larger and heavier parts it can handle, but I am going to be limited to some degree because I'm tilting that part. So there's going to be a limit on there that I wouldn't have on a standard 3-axis machine where I'm bolting it to the table. The other issue with the trunnion, as we talked about already, this is the one where I'm coming from the back. I'm going to reach down over the trunnion when it's at 90 degrees, and I have this collision issue that I want to think about here as well. So again, when I'm looking at an AC trunnion, which is an A-axis tilt, C-axis rotary, then I need to think about the size versus the parts I'm running and the tools. Next, we have a BC trunnion. Now, the C is basically the tilt is along the Y-axis. The C is under the Z. and I'm going to tilt left and right. Now I don't have to worry about reaching out over that that body of the trunnion, because the tool, the head will travel all the way to the positive X, rotate the tool or the table into position, and the tool will always approach from the side. So I'm never reaching out over that trunnion. So being able to run longer or shorter tools with larger parts or smaller parts now becomes more possible with a BC, because I don't have that interference issue. This particular style of BC trunnion, there's something else we need to think about, and that is the fact that the center line of rotation right here on the trunnion, the part that it rotates around, is very close to the surface of this table. So it may limit the size of parts that I'm able to run, because when I go 90 degrees, again, just like we saw on the other trunnion with Y, I only have so much travel in X. So being able to ask and find out what the distance from the table surface at 90 degrees to the center of the spindle at full maximum X travel, that is going to determine the height of the parts you can do. And again, it's something else, something you would want to ask. The part weight on this still could be limited because of it's a trunnion, so we're going to be tilting that part. But again, the larger the machine, obviously the heavier the part and the larger part. So that's going to sort of coincide with the machines that you pick and the parts that you're using. But the other benefit to BC Trunnion, other than being able to use standard link tools, is I'm going to be able to tilt beyond 90 degrees, both positive and negative of the tilting axis. So it's going to give me that undercut capability on both sides that I didn't have with the A axis because of the configuration of the head and the casting and so forth. Here's another BC Trunnion style machine. This is called the Cantilever or universal configuration. It's also a table because the tilting and rotary axis are both built into the table. Some of these designs will have this little support here. Some won't, depending on the model or brand of machine. But we have the same type of benefits we got on the other trunnion we just saw. The undercut capabilities, I can go plus or minus more than 90 degrees. Part weight may still be limited based on the trunnion's capacity. Typically a little heavier part on this machine because there's normally fewer sizes to choose from. So this is going to accommodate a larger range of size and weight. And that table now you see is a much more useful table for mounting multiple fixtures, a vise, things like that on than what we saw on the smaller round type trunnion. And in this particular case, on this style of BC trunnion, the universal, the center line of rotation being up about right here where my mouse is, you can see that the table surface is much lower than that. That is going to give me the ability to run taller parts. Again, when I rotate 90 degrees, positive or negative, I'll have X-axis travel that will get me to what would be the top of the part when it's rotated. But because that part is dropped below the center of rotation, I've got much more distance there that I could run taller parts. So this is a very good machine for a lot of, I don't know what I'm going to be doing. This kind of machine kind of lends itself to more of a job shop environment. I can do just about any type of work that might come in. It should fit this as long as it's within that work envelope that the machine builder is touting. Now we move to a BC swivel rotate. This is what we call a head table because the head tilts a little bit beyond 90 degrees both directions, and the rotary is built into the table. So we have a head table. Some of the benefits of this style of machine is this table and rotary are flush. So I could do some plate work or very long pieces that are bolting straight to the table where I'm going to maybe work on a 3-axis or 4-axis type work where I could just drill some angled holes or drill and tap some holes in a plate. I have this flat section of the table here to the left where I can put 1, 2, 3 vices depending on the size of my machine to get some 3-axis work done or do what we call the 5th or the 6th side of the part. Maybe I'm getting that part prepped for it to go on some work holding that I'm going to do 5-axis work on over here on the Rotary. But it's a very, very versatile type setup because of the different ways that I can fixture the parts and the different types of work I can do. The other thing, this is the first one where we see the trunnion go away. I don't tilt this part anymore. The head tilts around the part. Therefore, the weight of the parts that are capable on this machine go up because all the weight is going to be distributed through the table, through the base, through the casting, and right down to the floor. So since I'm not tilting that part back and forth anymore, I'm going to be able to travel and handle a little bit heavier part. One of the things you do want to make sure you find out here is when I've got this head tilted at 90 degrees, I want to know how much distance from the center of the tool to the top of the table do I have? So how close can I get to that table when I'm all the way down in -Z? That's going to determine the height of my part and fixture work that I need if I'm going to be doing some work at full 90 degrees. If I want to be able to reach the bottom of that part that I have on the fixture, I need to make sure it's high enough off of the table that I can reach it. So that's one of the things that you want to find out when you're purchasing a machine like this. What is that distance? How much or how close to the table can I get at 90? Here we see an articulating head. This is typically something we see on larger machines. It's a head design. The head or the rotation and the tilting are both done here in the head. And again, typically on a very large bridge style machine where we're running heavy, big work back and forth that needs to be supported well because it's extremely heavy and we cannot articulate that part because of the size and weight. That's where everything happens in the head. We're able to rotate this 360 degrees. It tilts back and forth, usually just a little above 90 degrees, and gives you the flexibility you need to do the type of work you would do on a machine like this. Once again, you're going to want to know what the distance from the center line of the spindle at 90 degrees to the top of the table, because any work you're doing on the side of the part at 90, we're going to want to know what that measurement is. How close can I get? How high do I need to bring up my part, if any at all? And the last consideration here is an add-on table. This gives you flexibility to take an existing 3-axis machine, invest in a table like this, add it to the existing machine you have, and now you have some 5-sided or 5-axis capabilities without putting a new machine in your shop. This also is a table design because this type of trunnion, the table, the rotary, and the tilting are both on the unit itself. And whether this is an A axis with a C, a B, C, or an AB depends on how you mount it on the machine. And when you tell it to go to 0, where does it go? What orientation is 0, 0 on this particular unit? That'll tell you what the configuration is. But depending on the kind of work you're doing, there are benefits to each one of those designs, similar to what we talked about in the dedicated machines. But with this, you gain flexibility, but you are going to lose some machining envelope. Obviously, this is going to, especially in the Z, eat up into the Z-axis travel or the working envelope of the machine because it's just building up on top of the table. So it's something that'll be high that you have to work around to either get up over it. If you're running your work pointing up towards the spindle, obviously you've got the height of the trunnion plus the part, the fixture, whatnot, to really eat into that Z-axis. So although very flexible, it's pretty much dedicated to much smaller work. And because of that, the way that we're tilting it and the fact that it's not dedicated, again, you're limited in your weight and the capacity that this particular configuration offers. So that brings me to the end of what I had today. Hopefully you were able to get something out of this, and we can open it up to questions now, I guess.
Thanks, Mike. Really appreciate it. So I'll start with a few questions. First one being, what is the most flexible or useful work holding type for 5-axis?
If I can, well, it's pretty far up in the presentation, but I would say that centering vise that we saw, typically that gets mounted on the table of the machine, And as you close the vise using the handles, both of those jaws move in simultaneously, and it centers that part no matter where you are in travel. So that kind of gives you a good, whether you're brought that in and you're clamping on the inside of the part, if you're clamping on the outside, it gives you a pretty wide flexibility range there of work that you can clamp without having to dedicate it to a secondary operation of putting dovetails or something like that in there. So I would say the centering vise is probably the most versatile and flexible.
Awesome. Next one is, if you had to pick one, which 5-axis machine configuration would you say is the most versatile for a job shop environment?
Probably the cantilever or universal style. Again, we've got that very large table to hold a variety of work or fixturing options. And because it's a B-axis tilt, we're able to reduce the length of our tools and get a little more traditional on our machining capabilities there. So I would say that. If the budget allows, the swivel head we talked about has that very long table that I could put some plate work on. I could do some 5-axis work. That's probably the most versatile, but typically those are pretty high in the cost range. So unless you have other benefits to that, I would say that cantilever or universal style.
Gotcha. And next up, how much experience do you need to operate a 5-axis machine? Can someone who is new to CNC with little or no experience run a 5-axis machine? Yeah.
Absolutely. So going from 3-axis to 5-sided machining, again, we're taking all of the tribal knowledge or the knowledge that you're going to need to do simultaneous out of it. So we're going to touch the tools off same way. You're going to pick up your part 0 wherever you're referencing your work offset, same way. And we're going to have to learn a little bit with a cam system that you're using, or if you're using a conversational control, how do I position that part and then temporarily move 0 to machine that particular feature, and then I'll cancel that and I'll go right back to the original setup. So I would just continue that throughout the part. So very, very simple concept going from 3-axis to 5-sided. Going from 3-axis or 5-sided to simultaneous, that's going to take a little longer because now nothing on the machine side, but now you have to learn the new tool paths in the cam system. If you're programming simultaneous, you're going to have to learn how to use each one of those, how to apply them, what kind of constraints for the tool and things like that. So going from 3-axis to 5-sided, it's extremely easy. Really not much you have to be worried about. It's that full jump to 5 where we probably want to make that step in between, and that's really where the difficulty might lie. Again, it's not in the machining part of it, it's in the cam system. And if you're good at cam systems and you pick those up well, that shouldn't be that difficult.
Got it. And next up, are the rotary tables removable and can be placed back on when needed on a 3-axis table?
Yes, they are. What we have to think about, though, is if you're going to put that on and off often, you're going to want to key it to the table, pin it, or something, because every time that comes on or off, we have to measure the center lines of rotation. And that is from machine home to wherever that happens to tilt or rotate around. And that has to be very accurate. If we don't have that measurement very accurate, then our parts aren't going to be accurate. So the more repeatable we can make that, when we remove that from the work envelope and then put it back, the quicker we'll be able to get to making chips again. So yes, it is very possible. You just have to do a little forethought and make sure that you have that worked out before, so you're not remeasuring literally every time. If you have probing or centerline probing available on the machine that you have, and you can do that very quickly, that's going to be a plus. But if it's the typical job shop that doesn't have that type of thing, I would recommend keying or pinning that somehow. So when you take it off, put it back, it's pretty much where it came off from.
For sure. Next up, so if I want to start my own shop, could I start directly with 5-axis?
Yes. Quite honestly, what we see is anyone who's starting a new machine shop, and they're going to be limited in time, limited in resources. They're not going to have a lot of people to draw from or a lot of spindles. 5-axis machines with some type of automation seems to make the most sense, because you're going to be able to gain more hours in the day, and you're going to incur that kind of right off the get-go when you're starting anyway. So I think the return on investment is pretty quick there. If I were to start a shop again, I noticed I know in my biology earlier, they mentioned that I came from a job shop that I owned before I came here. Had I known then what I know now, I definitely would have bought a 5-axis machine, because we handled those parts every time that we would do a job. We handled multiple operations, and I'd be able to fixture and do those parts much quicker and more efficiently. So yeah, definitely a new shop, I think, would benefit more even than a shop that's been around for a long time, because they have those resources where a new shop doesn't yet.
Got it. And next up, on the BC swivel rotate machine, you mentioned using a vise off to the side for machining the 6th side. If you were doing work on all 5 sides at 90 degrees, wouldn't you limit the ability to have vices off to the side of the rotary because of the head rotating down and hitting those vices?
Yes and no. So yes, you would, depending on how tall the setup is on those vices. But again, I told you we need to know what that distance is off the table when the head's at 90 degrees. And on Hurco, for example, depending on the size of machine, that is high enough that it doesn't really hinder you from doing larger work on the rotary, but it is tall enough to allow you to clear standard or traditional height 6 or 8 inch vices with some parts in them over there. So yes, it very well could. So you're going to have to be careful of that. But they've kind of worked that buffer, if you will, into the bottom of the Z-axis travel, so you aren't running into that.
Gotcha. And next up, typically 5-axis machines come with 30 or 60 or 120 automatic tool changer. Do you find 30 tools to be too low, or do most people require 60 plus tools?
It depends on the type of work you're doing, because you are definitely going to want more tools than you typically would have in a 3-axis setup, because you're going to be doing multiple operations. But quite often we see them utilizing the same tools in those operations, so it kind of is a wash. But yes, the more tools you can get, obviously the more flexibility you have, and the more opportunities you'll have to do even more operations. So 30 is a good number because it's a pretty common number across the board. Again, because a lot of those tools are redundant on multiple operations. But if you have something that's very specialized on multiple sides, obviously the more tools you can get, that's going to be very similar to a horizontal. More tools you can get, the more opportunities and the more flexibility you're going to have.
Definitely. And then this next one is, do you recommend using a CAM system with 5-axis? Just kind of some recommendations on what software you use, what features should kind of be included in those.
Well, pretty much all of them. And I'm from Bobcat on up, they have all really, really stepped up their game. So if you've got something in your shop, the chances are they have a really good 5-axis system that you can go with, and you sort of upgrade what you already have. I wouldn't say that there's any that really stand out over the others. I wouldn't take someone who was a Mastercam user, for example, and tell them, oh, if you're going to do 5-axis, you need to go to X, Y, and Z or whatever, because they all are doing it pretty well. Fusion 360 even is something that we use here at Hurco. We use Mastercam, Fusion 360, WorkNC, and the guys have their own favorite system that they use, but they all do a really good job. Again, I mentioned Bobcat. I mean, especially for 3+2, even that used to be a very low end, but not anymore. They've really even stepped up. So I would say that which system you pick is probably less important than your knowledge of the system that you pick, if that makes any sense. They all do 5-axis pretty well.
Definitely. And one says, I'm interested in buying the model VMX42 SRTI XP, but I'm not sure if I have to buy a CAM software to operate the machine properly.
Job shop environment or 3+2 work, no, you wouldn't, because Hurco's we're known for our conversational. So there's a lot. You can go out on our YouTube channel. We've got some examples where we're programming some things 5-sided using the conversational. So you definitely could use that. If you did have a 3-axis cam system, you can also merge our conversational with NC, so we can use conversational transform planes to orient the part and move work 0, and then call in our existing 3-axis program. So there are some ways to do it without having to go with that large expense. Obviously, if you're going to be doing simultaneous machining, you have to have a cam system. So we don't have anything for that, but there are things you can do without having the expense of a cam system, especially if you're looking at a Hurco.
Got it. And next one says, what's the difference in rigidity between the trunnion and swivel head?
Well, the tilting axis is going to be the weak point in either. Neither one of them are light duty by any means. And I would say, depending on how hard you push it, you could affect that rigidity on either one of those. On a swivel head, we've got the point here. You've got 9.5, 10 inches to the face of the spindle, and then you have whatever length of tool you have hanging out of there. So you've got a pretty large fulcrum if you were trying to overtax it. Again, these are hydraulically clamped. They're not going to move easily. So it's not really an issue we see, but that would be where the weak point might be. And on a trunnion, it's going to be in that worm gear that tilts that. Again, the machines, machine builders now, they're taking the size of the equipment that they're creating, and they're sort of gauging all of that based on the kind of work that it's going to be running. So it's not really a consideration anymore, anything that I would be concerned about, but it is a good question. And it's I would say that out of the two, the swivel head with that big long tool hanging out the end of the spindle is going to give you probably a little more chance for an issue if you're trying to overtax it than you would see ever with a trunnion.
Got it. And next one says, for 5-axis, when you do mass production, how do you deal with work holding parts for Op2? Is there any ways to do it all fast? Wouldn't I need a nested vise for Op2?
Nested vise, if you've got the table space to put multiple vices, you could do that. You'll notice that a lot of those, the ones we saw that were holding multiple parts, some of those you would obviously have an Op1 on this side of these two, for example, and then I would have to flip those for Op2 on the other. Still, though, every time I open that door, I'm going to be getting multiple parts, more than one, off at a time that are complete. So, again, 5-axis fixturing and work holding, that is just as creative as you can get. That's where it all is. And typically, just taking apart and tipping it, 45 degrees this way or turning it allows me to hit more sides of it. And then if I can get around those parts by putting more on the table, make my own fixture, use some Mighty Bite clamps or whatever to create that. But we very often will see Operation 1 and Operation 2 on the same setup, and then Op 2, every time the door opens, that part comes off complete. Hopefully that answers the question.
Yeah, next one is through spindle coolant worth the extra cost in 5-axis, or does an air blast get the job done in this type of work setup?
For drilling, you really can't beat through the spindle coolant, obviously. But if you are just doing a lot of machining other than aluminum, for example, air blast is probably a good way to go. It's going to keep you from having the coolant issues, especially with that tool tilting and rotating around. It's going to throw stuff up on the window. You won't be able to see when you really need to be able to look in there and look for possible collisions or seeing things move. So you're turning coolant on and off a lot. So I would say that through the spindle coolant, if you're doing a lot of drilling, especially deep drilling, it's worth its weight in gold. But if not, and you can get away with just using the air blast for most of the machining, that's probably the way we see a lot of people going, and that's what we try to do here as much as we can.
For sure. And next one is, what is the biggest hurdle when jumping to 5-axis machining from 3-axis? Sorry, did you get that one?
Nope. You went away. What is the biggest? And then you went away.
Oh, sorry about that. What is the biggest hurdle when jumping to 5-axis machining from 3-axis?
It's going to be the cam system. I mean, again, there are so many more controls, different tool paths, Some of those tool paths will behave the same, but are one or the other might be a better choice for the specific thing that you're doing. And learning that what's best for my particular application, that's going to be by far the longest learning curve and the hardest thing to do. Going from 3-axis to 5-sided, again, that's a very simple thing. As long as you can wrap your mind around tilting that part and locking it down and not having to do that manually with a fixture, then it's very simple because it's 3-axis work. But that cam system definitely can add a lot of complexity to it, especially in the beginning.
For sure. And this one says, is the future of machining an indexable cutters, or are solid end mills just too good to be replaced by indexables?
I still love my solid carbide for a lot of things, but indexable, I guess it depends on the size of the shop. I'm going to go back to my shop, for example. We used a lot of solid carbide and high-speed steel and cobalt because that holder was very expensive. The inserts were expensive, and we weren't large enough to buy a lot of that. So if we had an expensive high feed mill in there with some inserts in it, and that thing went, it wiped out the inserts, which might be, $20-$30 a piece. It took the holder, everything. So I still find it hard to get away too much from the solid carbide and the regular stick tooling, but definitely the efficiency is there in the high feed stuff and so forth with the indexable tools that they can't be ignored. That's for sure.
Got it. Looks like that's all we've got. So this might be a good spot to wrap up. Thank you, Mike.
Thank you.
And I also just want to thank Hurco for making the webinar possible. Thank you to everyone for listening in. You should receive an email with a link to the recording within the next few hours. So with that, thank you for joining us and enjoy the rest of your day.
All right. Thank you.